Hello, everyone. Today is April 17, 2024. This is the Cluster API office hour meetings. Before starting, just a reminder that we act upon the CNCF code of control, so be kind of each other. We have a agenda doc, which I've shared in the Zoom chat. In order to open it, you have to be member of the SIG cluster Lifecycle mailing list. If you please add your name to the attendee list. I see some folks are already doing it. Thank you very much. And if you have topic, please add them to the agenda. And so, as usual, when we start our meeting, we give some time to newcomers to speak up. So if you are new to this meeting, you want to introduce yourself, please raise your hand using the Zoom feature, and I will give you a room for you to speak. Okay, I don't see newcomers to this week. Then usually we look through open proposal, but we don't have an open proposal at the moment, so we can skip this one and jump into discussion topic. Mike, the first one is on you.
Yeah, thank you, Fabrizio. Let me turn my camera on here. So this is a topic that I wanted to get into about infrastructure machine templates and could we use them more than we are today? And I want to say, like, about 2 years ago, we put up the enhancement for the scale from zero stuff for cluster autoscaler. And in that enhancement, we included, an opt-in ability for providers to have an optional status section if they wanted to in their in their infrastructure template. And in that status section, they could indicate the capacity of the nodes that would be created by that machine template. And this has been like really useful. It's not implemented in all the providers, but like it allows us a way for providers to give that information to like, an auto scaling type process. So in the context of like cluster autoscaler and Carpenter, and as we're doing more integration work with these, being able to get like deeper information from the instance types would really unlock additional functionality from these other programs that I think like our community would be interested in. And probably like the biggest one of those would be like pricing information, right? Like if there were a way to signal pricing information about nodes or about instances, then we could propagate that information up to something like the cluster autoscaler or something like Carpenter. And then they could take that information into account when planning, new cluster topologies and everything. So really, the point of talking about this today is I wanted to open a discussion about this, maybe learn about a little bit about the history of how we did those, how we did those infrastructure machine templates to begin with. Maybe there's a reason why we don't want to have, more information on them. And really just start thinking about this in terms of future possibilities, because we're working on a cluster API provider for Carpenter now, but when that is complete, I think people are going to be expecting, or at least, users will be expecting that, they could turn on like the pricing options that Carpenter has, because that's one of the things that gets a lot of discussion in the community is that, Carpenter has these great options for looking at pricing information. And even, Cluster Autoscaler has an option to use a least price expansion methodology when creating new nodes. So, but we've never exposed that pricing information to cluster autoscaler, so none of that has ever been available to us. So I'm curious, like, does anyone think this is a good idea? Does anyone think it's a bad idea? Are people interested in this? Is there something I'm completely overlooking, or, would there be a good place to continue this discussion? Like, what do people think? Mike, I see you got your hand up.
Yeah, I know. I mean, I'm moving towards carpenter for stuff, so my comments are a little bit late for this. But prior to that, having the cost information, be able to use that cost expander would definitely be something of value. Um, so that kind of stuff is always forefront in my mind. So granted, I'm moving to carpenter, so that's less valuable, but
Right.
just a couple months ago, it would have been extremely valuable.
Right. But even in Carpenter, if for users who end up using the cluster API provider for Carpenter, we're definitely going to want those things,
Yeah.
exposed. So it's kind of like we get them for both if we're able to figure out how to do this. Thanks, Mike. Yeah, really appreciate the thoughts. Does anyone else have thoughts about this?
Sorry, I cannot raise my hand because I'm host, but
Right. Yeah, totally.
but yeah, I think that there are a couple of angles. So first of all, the problem, the problem statement, those information could be valuable. We need a way to manage them. I think that's that's a good and interesting ask. Okay, then there is the second dimension, how to implement these. So yeah, you started talking about machine infrastructure, machine templates. Let me say those things were originally designed to be templates. It is just a stamp. It is not designed to describe the status of a single machine or the status of a set of machines. So, and second, I'm also kind of thinking that maybe those are attributes that, yeah, for CAPI we think about machine, but if we think of Kubernetes in a more generic way, we should think about nodes. So it could be interesting a way to define them at node level. But yeah, this is the second part. So how do we model them? Maybe the template is not the right thing to describe this problem, but this is really up to discussion. And second, I think that the another angle of this is that I'm not is there a, let me say, a consensus about how to model prices across different cloud templates, cloud providers, stuff like that. This, probably there is a sort of consensus about how to model resources that a machine or a node offer, but I'm not sure about the price. So yeah, definitely interesting topic how to model it. I don't have a good answer. My gut feeling is that maybe infrastructure template are not the right place.
Really appreciate that, Fabrizio. And this is exactly kind of what I was curious to learn is some of the history there. So that it totally makes sense to me what you're talking about in terms of, the template is like a stamp, right? So like knowing the capacity of that template is one thing, like knowing the CPU and the memory and whatnot. But it's not tied specifically to to a specific like instance SKU or whatever in the infrastructure provider. And I think I hate to bring up the notion of trying to suggest like new API objects because I wouldn't want to do that if we could avoid it. But like maybe there needs to be some way for a provider to inform about, from a template to, like the SKU that it comes from for the purposes of learning information. And that might be filtered by like, region and zone and, other types of things. But from the perspective of when we look at this from the perspective of things that are trying to automate machinery, right? Like the way that the autoscalers have been built, is usually to talk directly to the cloud providers. But the metaphor that I've been coming up with in my own head is that when we're using cluster API, the cluster itself is the cloud provider. And so can we develop a way that someone could have a more rich experience for the purposes of building these higher order tools that could then automate on information that normally requires a specific implementation, for each provider, basically. And maybe this is abstracting information too much. But I think if we can learn about this problem now, this is going to shape the way that our carpenter experience goes in the future. Because if we don't expose any of this kind of pricing information and whatnot, then I think carpenter becomes less attractive to some parts of the community because you take out one of the big kind of features it has, which is the ability to kind of save money, by doing things like consolidating the cluster and whatnot. It's still interesting as an autoscaler with other features that it has, like its disruption features. But some of this pricing information is what a lot of people are gravitating towards these days.
Yep, I just want to give probably an unpopular opinion about adding CRDs. I don't think that additional CRD are bad if those CRD are managed by controller. So if you think to a Kubernetes deployment, behind the scene, it generates a bunch of CRD or types, but the user has to deal only with one. And this is not an issue, the fact that there are replica set and pods and whatever behind the scene. Because the user has to deal only with one, which is the deployment. If we can, apply the same pattern that the user just have to deal with the cluster object or with the machine deployment object, and everything happens automatically behind the scene, I don't think that additional CRD are evil. But yeah, I know that this is unpopular, so.
Totally. But I really appreciate the unpopularity of that opinion, because I'll just start making sandcastles if you put me in the sandbox, so. I guess, like, does anyone else have thoughts about this or comments they want to add? I'll probably go do some research about some of the things we're talking about here, maybe just to try and push this forward. But thank you, Fabrizio and Mike. And I see Richard's got his hand up. Please, Richard.
Yeah, I guess it's not directly related to the carpenter aspect of this, but a request that I often hear is, given the shape of this cluster, how much is it going to cost me if I create it? So we've had an issue in Kappa for a long time based on the template. This cluster is going to cost you $80 a month. So it feels like that information that you're talking about there could also drive some tooling and an experience around that the customers often ask for.
Christian.
Yeah, that's a great point, Richard. And that's kind of exactly the direction that I was thinking with some of this, is that although, I'm looking at this from the perspective of like Carpenter and Cluster Autoscaler, but there's a kind of a wider interest. It's exactly what you're saying. Like, if I could query a Kubernetes management cluster, like if I had a cluster API management cluster and I could give it some manifest to like my tooling, and my tooling could tell me, hey, this is how much your cluster will cost to operate per hour or something, like, yeah, that would be really interesting. This has kicked up more hands, which is cool. So Christian, please.
Yeah, I just wanted to mention, I initially followed your thought of having it at the template, makes sense, but then thinking about availability zones makes it maybe not a good fit, because you have different availability zones, and though different machine deployments, maybe using the same template, and then depending on which availability zone you land in, you have different prices, or you have other cloud providers or implementations which don't even have such a concept where it wouldn't match again. So yeah, I also think template might not be the best place to have it, but also don't have a better option. that case.
Cool, Andrea, and thank you, Christian.
Hello. I was just thinking, maybe it is a dumb idea, but maybe the infrastructure providers could just calculate a weight for a node, and that could have a meaning within the infrastructure provider. But then the interface would be just a number. Because price, I agree that it is hard to model price, because I think it does have different meanings in different contexts. Like I'm looking from the bare metal infrastructure provider perspective. But it would be interesting if I can prioritize nodes which cost less. And if somehow if the infrastructure provider can give that information about how heavy is this node, whatever that means.
That's a really nice idea, Andrea. Thank you. Thank you for sharing that. So I realize we've talked about this probably for like 10 or 15 minutes now. I see Stefan has a question in chat here. Is there something like one price for a certain instance type? Doesn't this also depend on customer contracts? Yeah, it absolutely does, Stefan. And I think this is where it would become complicated, because many, like a provider would have to be updating that information based on, the cloud credentials that you're giving it and whatnot. And so you're absolutely right. Like certain instance types in certain regions, your account might have paid for a discount on those things. And those will be some of the difficult questions to answer. But I think that would come down to the way that this gets expressed. Like if we could figure out how to make this work from a data perspective, then the next question would be, each provider is going to have to be doing some sort of reconciling where they're looking at an instance type or SKU per moment and saying, okay, the price for this is now changing to something else and needs to be updated. And, perhaps that's based on the user's identifier, how they're logged into the cloud. So I think you're absolutely right about that question. I'll try to copy it here for the notes. Thank you, Stefan.
There is also a question from Lubomir.
Yeah, I think these could be annotations. That's certainly one way we could look at it for sure. And those annotations could be on any of the objects that I think we think about. So that's another option.
Sorry. I don't think that annotation are a good fit for expressing such complex things as pricing, but this is an implementation detail we can discuss when we understand the data model. Daniel.
Yeah, I just had a crazy idea, I guess. Sorry for, again, same thing, probably proposing some implementations, but when it comes to templates, there's like runtime SDKs, and potentially the value of essentially the cost of the machine can be evaluated before creation as a part of templating procedure, and then decide upon that if it has a place in terms of scheduling the machine or not. Just thinking out loud. Maybe someone find this making sense in some way.
Yeah, no, appreciate the thoughts. Like this is good. I'm taking notes. Please, Guillermo.
Hey, sorry, I don't have a solution, but I have a question for you, Mike. So how are you planning on modeling this decision on Carpenter, right? So at the end, Carpenter is trying to make this decision. What type of instance or machine do I create to minimize costs, right? So it's kind of like a max min. How can I allocate the maximum amount of workloads with the minimum amount of cost? So it needs the price information to make those decisions. But how do you plan on modeling the AWS native way that Carpenter does is very easy, right? Like I have this catalog of instances, right? As big as it can. I can hit the API prices, so it tells me in this specific region, this specific AC, this specific configuration, how much it's going to cost. So I can do that algorithmically. But how is the decision going to be made on copy? What is the interface that Carpenter uses to communicate with copy?
Yeah, it's a great question, Guillermo. And I've kind of been working towards putting together a slide deck that I'd like to come here and present on the architecture that I've been kind of playing with so far in the proof of concept. But this is why I'm focusing on the infrastructure templates, because the way that this has been working so far is that we've been having Carpenter we want to push Carpenter into a mode where it creates like orphan machines, right? So it doesn't have to have a machine set or a machine deployment associated with the machine, because we're not going to be using those structures to control them. So we have a machine and we have like the infrastructure template that's associated with it from the provider. And maybe we have like a bootstrap config and kind of the other things that go into making it. And so the way that I'm, in the experiment, the way that I'm processing this currently is Carpenter has an object that it calls a node pool. And that's how you define how Carpenter can create nodes. In the node pool is a reference to something that you call a node class. And the node class is provider specific. So in our case, we'll have a cluster API node class. That node class defines how nodes are created from the provider. And so our node class, the way I'm experimenting with it to begin with, is that it will have a reference to the type of infrastructure template, like, for example, infrastructure Docker machine template or something, right? And then it will have a list of names of templates to bring up, right? And so when Carpenter asks, what type of instances will you get? Our controller will get all the infrastructure machine templates that it's been instructed to by the node class. And then it will turn those templates, it will look at the basic level, because we're not doing price right now. It will look at the status block to see the capacity information for those nodes. And then it will create a series of what are called instance objects that get passed back to the Carpenter core. Those instance objects contain like a requirements block in them. And that requirements block has has the information that Carpenter needs to be able to calculate, which node should it create next. And it does. And then, so what we'll do then is Carpenter will essentially be asking for a node claim by asking for the infrastructure machine template that it thinks will fit what's needs to be made. And then we'll make that. Now, what I'm hoping is that if there were a way to expose the price information through the infrastructure machine template, then that information could be added to the requirements or the constraints block, whatever it's called, that gets sent back to Carpenter. And we'll be following the same methodology that they use, which I think is like a weighting kind of system like Andrea was talking about. And it works, this works on Azure and on AWS. So it is being done in the core Carpenter through these structures that are passed back. So does that help answer the question?
Yeah. It does.
Cool. Awesome.
Thank you.
So this is why I've been focusing on the infrastructure machine templates, because it would be convenient for us. But maybe there's another way to look at this too. And that's why I love hearing all the ideas here.
Yeah.
In the interest of time though, maybe we want to cut this off.
Yeah, I will give you a point, because it's something that also came up in some past meeting. So I think that another angle to look at this is that we should not put the complexity of on the users, basically. And so let me try to explain this. I don't think so. Honestly, I struggle a little bit to follow your explanation. I'm not a Carpenter expert, or I don't know it in so much detail. But I don't think that we should try to invent a new abstraction in cluster API for managing a set of nodes. Because this will be confusing. We already have machine deployment and machine pool, which probably was not a bad decision, was not a really good decision, because at the end they are set of machine. why are we making them different when the difference is just an implementation detail, how we build up machines? And so let's also consider the complexity that we are introducing about this. And this is another angle to look at this. Going back to the template, to infrastructure template, being them convenient, I think that we should apply the same angle. Is it convenient for us implementing it, or it is convenient for users? Because at the end, we should always favor it is convenient for users. And the last point is that now that came to my mind, one of the things that we have all around copy is the fact that we use template rotation to signal that we want to change the type of machines. And if you use if you use template rotation, might be that all the assumption that you are making about using infrastructure template as a way to convey information gets a little bit more complicated, because your template can continuously go away and new one are created.
I mean, it's perfect, Fabrizio. Thank you for adding those comments. I think what I'll probably do as an action item is I will go and form some of this and try to finish the slide deck I was talking about, and then come back and talk about this again, maybe next week or the week after. Because I think this is a topic that will probably, yeah, sorry.
Yeah, so it is, we are at alpha at the time. I will, if that's okay for you, I will leave room for Andrea for his last point. Then we we table this discussion, we go on with the agenda, and then eventually we come back to this later. Thank you. Please, Andrea.
Thank you. Just a little thing. This also makes the assumption that all the instances of one template are the same size or type and so on. And CAPI does not enforces that. So it is true probably for all the autoscalers, but not for all the infrastructure provider, I think. Even though it is probably a good practice.
If that's the case, I need to review that. I thought there was a one-to-one relationship.
Yeah, currently in Cluster API, a machine deployment has only one infrastructure template. A machine pool has only one infrastructure template. So we do not allow mixed machine types.
That is true, but then different machines could be different types. Like in bare metal, I could have one template, and then I could have one laptop and one Raspberry Pi. Nothing forbids me from doing that.
Yeah, that's true. I think we're good to move on, Fabrizio.
Okay, thank you. And thank you everyone for the interesting discussion. And thank you, Mike, for taking valuable notes in the agenda. So the next point is a really quick one, a PSA. So I've sent a PR where basically I implemented a triage party template for Cluster PI. And this is based on the new contributor guideline about how we triage issue. I'm testing it. Maybe as soon as it is decent, we could organize some triage session or use left time in this meeting to do public triage session. And yeah, if you're interested, take a look. Great. If there are no feedback, no question on this one, we move on to the next one, which is again on you, Mike.
My apologies for bringing up these, and this may be another one that could get long-winded. I don't know. So I'm here to ask, is anyone currently using the cluster autoscaler with more than like 50 or 100 machine sets or deployments in it? Don't be shy.
I'm not aware of folks running so many machine deployments or machine sets
Okay, so
with autoscaler.
Yeah, we've been doing some testing internally at Red Hat with larger groups of machine sets and machine deployments and whatnot, you know, like getting up above like 50, 100, 200, 500, those kind of things. And it looks like that we're seeing performance issues coming out of the cluster autoscaler based on the number of queries that the autoscaler is doing to the API server, because like every pass that the autoscaler makes, if it has to look up 100 machine sets or 200 machine sets, you know, it has to query those and then query the scale resources on them. And so what we're seeing is that it can take an excessively long time for the autoscaler to properly process pending nodes in clusters that have more than, like, once you get above 75 or 100, you could start to notice slowdowns of like 10 or 15 minutes sometimes, and how long it takes. And I think when you get north of multiple hundreds of nodes, it could end up taking 30, 40 minutes sometimes for the pods to get processed properly. So like, I'm just starting to look into this. Like, we've seen it come up before. I'm trying to understand it a little better, but I wanted to bring it up here to let the community know, and also just to, you know, look for collaborators who might want to, you know, get into some of this with me, trying to make it more efficient. Yeah, Stefan, I see you got your hand up.
Yep, I don't know enough about the cluster autoscaler, but it might make, depending on what it's actually exactly doing and what actually takes time, it might make sense to look into the improvements that we did in CAPI with 1.5, because we improve performance a lot, and a lot of those changes might also be applicable to cluster autoscaler. Also, shameless plug, Lisa and I did a talk at KubeCon Chicago about performance of controllers with controller runtime and how to optimize it. I can add both to the doc here.
Yeah, I'd love to take a look at that. And that's a great suggestion. I'll do that. I'll look at 1.5, because I think that we're probably doing it in a way that's very I don't know. It's probably not, it probably could be improved like performance wise. And I'm not good enough with like controller runtime and the client Go to, you know, to really just look at it and say, okay, yeah, do this and that. But I'll look at the code we have here. That's a great suggestion, Stefan.
Yeah, and adding a little bit on top of this, in cluster PI we have dashboard metrics setup that you can run with tilt, etc., etc. If you look at the talk, we are explaining all of these, give all the links, whatever, and yeah, really good point. And also, as Stefan brought up, when we did the scale testing, we did scale a lot to a lot of machine deployment. I don't remember the number that we ran exactly, but without autoscaler. And if I remember, Stefan, correct me if I'm wrong, at certain point we were seeing degrading the API server performance.
Yeah,
but yeah,
at various points during the optimizations. But
yeah. But yeah, we were also running stuff on a big machine and in a not production configuration. We were just stressing CAPI. But yeah, the talk give a lot of context, and it was also a fun job to do.
Cool. Oh, and now I know what I'm watching this afternoon. This does make me think about, you know, the metaphor that I used before, where like, you know, the cluster becomes the cloud provider, basically. This starts to make me think, though, that we're probably seeing like a reflected version of the same kind of problems that cloud providers deal with internally, right? Like, how do you query the API servers for like hundreds or thousands of machines at a time, right? And it's like, we're doing the same thing now, but we're querying Kubernetes as like our internal API to say, okay, give me all these machines and everything. So, you know, yeah, like maybe I think just looking at it from the perspective of like, how do we make this better? I'll start by looking at the CAPI stuff, because like I just want to trust that in my mind, like, you all solved it already, and I can just copy everything you did and put it right in the cluster autoscaler. So I'll keep living with that fantasy. Stefan.
Yeah, so on the issue I linked, we had like, I think we linked like 20 or 30 PRs where we improved the performance in core capping. So, and it's like basically like 3, 4, 5 main points, and they show up in the talk again. So
Okay.
I think that
I've got
helps.
some reading to do then.
And I don't know how it's applicable to cluster autoscaler, but you were saying that you're talking a lot to the API server. I think basically once we're done with that, I would just a wild guess, but I guess like over 95% of our calls to the API server are not actually going to the API server. They're just hitting the local cache. So that was like one of the really biggest improvements that we made to make everything very quick.
I think that's probably something, if we could make more use of the cache in the cluster autoscaler, yeah, it'll probably make a huge difference there. But then I also start to wonder, like, okay, what is the cache invalidation time like on those things? Like, how frequently does it refresh because we always get users who are like, oh, like it did, the autoscaler didn't react immediately when I did something, it's like, okay, well, if it takes longer for the cache to update, those kind of things.
Yeah, basically, I don't know if it makes sense to give like a high level take on that, but I mean, in our situation, it was basically like this. It could happen that we hit cases where we are working on slightly outdated data, but the way that we are watching on objects, we basically know that at some point we will get an event for an up-to-date object that will trigger another reconcile, and in that reconcile, we know that everything is up to date. And as long as everything is behaving relatively normal, the latency between something happens in the API server, you get a watch event, and if your queue is empty, you actually get a reconcile. I mean, I would expect it's a few milliseconds at most. Assuming that your queue is empty, that's the main thing. If your reconcile is quick, you keep your queue empty, and then it's not really a matter of that you're far behind. It's just, yeah, I mean, the object could be a few milliseconds late. It's like the normal thing.
Right.
But I mean, nothing actually happens at the same time anyway.
Right. Yeah, totally. Okay. Yeah, I mean, this is great. Oh, sorry.
Great. Thank you for another interesting discussion. And if you have questions about the work for the optimization, feel free to come back to us. Okay. Next up, Adil.
Yes. I have this PR. It already has a LGTM. I've been asked to add unit test and do some improvements by Fabrizio and Stefan. I have done those improvements. If I can get to prove, it would be nice. I was also wanted to ask, can we add it to 1.7, maybe backport, or no? For the next patch release, or
So, yeah, first of all, thank you for this work and sorry for the lag. We were at least me and Stefan and Christian, we were mostly focused on having a look at test, preparing the Capillary release, and making sure that the release was able to go out. So if I remember well, this PR came up to when we were looking through PRs for the release, and we considered this a feature, and I'm not sure that it can be backported, but I have to look into it again. As Stefan is writing, we went through a bunch of PR and tried to get as much as possible merged. So yeah, please give me 1 or 2 more days, and then we will come back to you.
Okay.
And
no worries.
I take just a second since the topic came out. I want to give a huge shout out to the release team for yesterday release. And yeah, congratulations. I know that you held the retro right before this meeting. I will take a look, but really great work, folks.
Yep, thank you release team, and thank you everyone.
Okie dokie. So we are nearly at the end of our regular agenda, and we have provider updates. Matt.
Hey, just reporting in for Cluster API provider for Azure. We had a couple of patch releases, and we got 1.7.0 support merged. yesterday pretty quick, but that will not show up until we have a minor release, which is a couple weeks out. That's all.
Cool, thank you. It's always great to see how many caps release are you doing. It is amazing to see. Great work, folks. And then we have Mike about.
Stefan's got his hand raised. I don't know.
Sorry, Stefan.
Yeah, just we forgot to the agenda, but basically similar sort of for CapV. So we bumped to CapV 1.7 today. It's all green. We're planning to release CapV 1.10 probably next week with CapV 1.7. Thanks for your question.
Thank you. Mike, last point about the Carpenter feature group.
Yeah, if everyone's not sick of hearing from me yet. Yeah, there's Carpenter feature group meeting after this one. The agenda's there. We'll be getting into some of the technical topics that are kind of similar to what we were talking about earlier. So welcome to all.
Great. With this, we are at the end of our agenda. Is there some last minute topic? Cool. Thank you everyone for attending. Again, huge shout out to the release team and see you next week.
Thanks, Fabrizio, and thanks, release team.